Hi everyone. Today we're going to study law of growth and decay. Let capital N of T denote the amount of substance or population that is growing or decaying. If we assume that the time rate of change of this amount of substance, that is dN over dt, is proportional to the amount of substance present, in symbol we write dN over dt is proportional to capital N. In equation, we can write like this: dN over dt equals K times N. This K here is the constant of proportionality or continuous growth rate. If K is greater than 0, meaning if K is positive, the amount is increasing or growing. If K is less than 0 or negative, the amount is decreasing or decaying. In here, we assume that capital N of T is a differentiable and continuous function of time. Now let us solve this differential equation by separation of variables. The new equation becomes like this: dN over capital N equals K dt. Next is, let us take the integral of both sides. The left side becomes ln of capital N equals, the right side is now kt plus, we show that the constant is the natural log of this constant a. Next is, let us put the constant on the left side. It becomes negative ln of a. On the left side, let us apply the law of logarithm. So we have now this ln of the fraction n over a. On the next step, let us show that this left side and right side are exponent of the constant e. On the left side, it becomes the fraction n over a alone, while the right side becomes e that is raised to kt. And in this case, we're going to cross multiply this a to the right side. Then the n is isolated now. So the value of n is equal to a times e that is raised to the product kt. Let us regard this as equation number 1. Let us note that when t equals 0 or when time equals 0, then capital N is equal to capital N sub 0. When we substitute the corresponding values to equation 1, it becomes like this: n sub 0 is equal to a times e raised to the product k times 0. The k times 0 is simply 0, and this is now e raised to 0, and it becomes value 1. It means we can simplify this as n sub 0 is equal to a. Next is, we will substitute the value of a in equation 1. And equation 1 becomes n is equal to n sub 0 times e raised to the product kt. This is now equation 2. And this equation 2 is our working formula for this law of growth and decay. Example 1. A strain of bacteria growing on our desktop doubles every 5 minutes. Assuming that we start with only one bacterium, how many bacteria could be present at the end of 96 minutes? Let us write our formula for law of growth and decay. In this problem, let us regard this as equation number 1. If we analyze our problem here, we can see that at time equals 0, the n sub 0 equals 1. The step 1 is to substitute the value of n sub 0 in equation 1. So equation 1 becomes n equals 1 times e raised to kt. And we can simplify further into n equals e raised to kt. This is equation 2. Step 2, let us analyze the problem to get another given. Take note that the bacteria doubles every 5 minutes. We can conclude that when t equals 5, capital N equals 2. Substitute this value in equation 2 and then we will get the e raised to k. This is our equation 2. When we substitute, it becomes like this. The left side is 2 equals e raised to k times 5. The next step is we're going to raise this equation into power that is reciprocal to t or time. Our time here is 5, so the reciprocal is 1 over 5. In that case, the left side is 2 raised to 1 over 5 equals, the right side is e raised to k. And from here, the value of e raised to k is derived. Step 3, let us substitute the value of e raised to k in equation 2. Equation 2 is here and it becomes like this. N equals the quantity 2 raised to 1 over 5 and then this is raised to variable t. This is now equation number 3. At this point, we are now ready to answer the question in the problem. How many bacteria could be present at the end of 96 minutes? For step 4, we're going to substitute t equals 96 in equation 3. So equation 3 becomes like this. The t is changed into 96. We combine this 96 and the 1/5 and it becomes 96 over 5. Using our calculator, we are going to simplify 2 that is raised to 96 over 5. And the value of n is 602,248.76. This is the number of bacteria. This is the final answer. Example 2. A person had 3 mice in 2 months ago and now have 18. Assuming the growth continues like that, how many mice are there 2 months from now? How many mice will be after 1 year from now? Our formula is written here and this is our equation number 1. Next is, if we analyze our problem, it says that at time equals 0 month, the n sub 0 equals 3. So for step 1, we substitute the value of n sub 0 in equation 1. So this equation 1 here becomes n equals 3 times e raised to the product kt. This is now our equation 2. For step 2, let us analyze the problem to get another information. Take note that when t equals 2 months, the number of n is equal to 18, or the number of mice is 18. Therefore, we're going to substitute the corresponding values in equation number 2, and in that case, we will get e raised to k. Equation number 2 now here becomes 18 equals 3 times e raised to k times 2. We can simplify our equation by dividing by 3. The left side becomes 6 equals e raised to 2 times k. In this case, we are going to raise into power that is reciprocal to t. Our t here is 2. It means the reciprocal is 1/2. The left side now becomes 6 raised to 1/2 equals, we have the e raised to k. And from here, we know now the value of e raised to k. Next is, we substitute the value of e raised to k in equation 2. Again, this is our equation 2. When we substitute, it becomes like this. N equals 3 times the 6 raised to 1 half, that is raised to variable t. This is our equation number 3. When we reach this equation number 3, we are now ready to answer the questions. First is, how many mice are there 2 months from now? Take note that 2 months from now, and we have 2 months ago in the first sentence, which means our t is equal to 4 or 4 months. We substitute this value in equation number 3. So equation number 3 becomes like this. The t is now changed into 4. This exponent 4, if we multiply by 1 half and we simplify, it becomes 2. So we have 6 squared here. We can use our calculator to simplify the value. 6 squared is 36 times 3 will be 108. And we say this is the number of mice. This is the answer for our first question. Now, second question, I'm going to copy our formula number 3 in here. Second question now is, how many mice will be after 1 year from now? After 1 year from now means we're going to change this 1 year into months, and that will be 12. But in our problem, there were 2 months ago that happened. So the 12 plus the 2 means that t equals 14. Let us substitute this value of t in equation number 3. So equation number 3 becomes like this. We can simplify this 14 with the exponent 1 half, it becomes 7. We use our calculator to simplify this expression, and the final answer is 839,808. This is the number of mice. This is the final answer. Example 3. The half-life of caffeine in our body is about 6 hours. If we had 1 cup of coffee 9 hours ago, how much is left in our system? We write our equation here, and we regard this as equation number 1. When we analyze the problem, we can see that at time equals 0, the n sub 0 equals 1 dose of coffee. Step 1, we substitute the value of n sub 0 in equation 1. So equation 1 becomes like this, and we can simplify further the right side as e raised to kt. And this will be our equation number 2. Step 2, let us analyze the problem to get another information. In our first sentence here, we can see the word half-life, which means when t equals 6 hours, the n is equal to 0.5 dose of coffee. We substitute the corresponding values in equation number 2, and we will get the e raised to k value later. Equation number 2 becomes like this. And when we simplify, what we do is to raise into power that is reciprocal to t. Again, the t is the time, and that is 6. So the reciprocal is 1 over 6. The left side becomes 0.5 raised to the power 1 over 6 equals, the right side now is e raised to k. We can now see the value of e raised to k. And the next step, substitute the value of e raised to k in equation 2. Equation 2 now becomes like this. And we regard this now as equation number 3. When we reach the equation 3, we are now ready to solve the question in our problem. If we had 1 cup of coffee 9 hours ago, how much is left in our system? For step 4, we substitute t equals 9 in equation 3. So equation 3 becomes like this. The variable t is now changed into 9. We can simplify this 9 times 1 over 6, and when we simplify, it becomes 3 over 2. We can use our calculator to solve for 0.5, that is raised to 3 over 2. So the value will be 0.3536. This is the dose of coffee. This is the final answer. I hope you learned something from this video. See you again next time.